find dy dx for this function. This is called implicit differentiation. So the key here is that when I take the derivative with respect to x of a function that just has an x in it, that's simple. All I do is take the derivative like I'm used to, which would be 2x. But if I'm taking the derivative of something that doesn't have an x in it, like y, I need to keep that dy dx because y ultimately may eventually someday become some function of x, in which case I would plug the y in there and I would take the derivative, or I would plug the function in. So that's kind of like the thought behind what you're doing, and then you're using the same rules for differentiation. So what's the derivative? The derivative of this entire equation, I can distribute the derivative with respect to x into each one of these three terms. To take the derivative of this first, notice that that's a function of x. It's just going to be 4x cubed. That's all I have to do because it's a function of x. This is not a function of x. So I have to take the derivative. This is the chain rule. I have to take the... How would you take the derivative of something squared? How would you take the derivative of that? You would first take the derivative of the outside without changing the inside, and then you would multiply that by the derivative of the inside, whatever that is, which is u in this case, with respect to x. So that's what I'm doing. So I'm going to take the derivative of this outer function y squared, which is 2y, but then I'm going to multiply that by the derivative of y with respect to x. Again, assuming that y is some function of x. And then same thing with this other side. This is going to be even trickier because now I got a product rule. So let's go through this and take the derivative of this product with respect to x. Remember, the product rule is it is the first function, which is x to the fifth, times the derivative of the second. And again, the derivative of the second is going to be the derivative of the outside, which is 4y cubed, times the derivative of y with respect to x, because that's the chain rule, plus the second times the derivative of the first, which is simply 5x to the fourth, because that is a function of x. All right, now that I've done that, I need to clean this up, and remember, I'm trying to find dy dx, so I need to take these two things, pretend like this is some new variable like u or something. So to do that, I'm going to have to move things around, and I'm going to move these terms to the same side and these terms to the same side. So let's since this is a minus right here, let's move those to the right, and let's move these to the left. So it's 4x cubed minus 5x to the fourth, y to the fourth, equals, I'm moving this now to the right side. This is already there, so I'll write that first. X to the fifth, 4x to the fifth, y to the third. I'm cleaning it up as I'm writing it. dy dx plus 2y dy dx. And now I can take the dy dx and factor that out of both sides. I'll go ahead and do that here. Most calc students would be able to do this kind of in their head. That's a simple enough thing to do in their head. There's that equals this over here, 4x cubed minus 5x to the fourth, y to the fourth. And so now I'm going to divide this over here, 4x to the fifth, y to the third plus 2y. And now I can delete and get rid of that, and there's your answer right there. That's dy dx, which again, let me explain what that means. That means that this is the change in y with respect to x. That's how y changes with respect to x. Now, notice we have y's in here, but what you may determine at a later point is, oh, well, y, it was a function of x. Y was equal to 3x squared minus 2. In which case, oh, now you can plug those things back in for these y's right here, and right there, and right there. and then you'll have a function just of x. Then you'll have everything in terms just of one variable x. But that's for a little bit later down the road.